Hello, everyone. Welcome to our class. Today, we will start to talk about the sharing for the thread. So, what makes a thread powerful? Share, because it's easy to share the data between the thread in a process. By using global variable, static variable, the thread can easily communicate to other thread. So, if you want to implement a code which has a lot of interaction between different tasks, between different control flow, then of course the sharing in this thread can make it a really good choice for your program. Okay, but the sharing also brings some dangerous behavior in your program, and this thread bug is really hard to debug. It's hard to find. Why? Because it won't give you something like a segmental form. It's just give you some like a data, like a result, and unexpected result. And it's not every time. Maybe you run like 100 times, you only see this result once, this weird result once. So it's hard to debug because it's hard to reproduce the result, the unintended result. So let's talk about the unintended sharing today. Okay, so let's see this example. This example is very simple. The first one, the main thread try to use a while loop. Inside this while loop, it just create a lot of peer thread. Actually, let's create 10 peer thread. And each peer thread, before you do this, you try to open a file. So you open a file, and for each peer thread, you can use different file. This is the logic. Okay, so why we decide this? Because fd is a local variable, belong to a main. So it's only belong to the main function, main thread. Okay, so inside each thread, they have its own arguments. This one, vargp. So they have their vargp, these arguments. So this is local variable. So we try to pass the value in the main thread. We try to pass the different file to different thread. This is the on purpose because we have a local variable here. So we believe it's safe, but actually it's not. It's dangerous sharing. So sometimes it's on purpose. Sometimes you want to do this sharing. It's on purpose. Sometimes it's not. So in this case, you need to know, do you have a sharing here? Yes, there's a sharing. Why? Because you pass the value, you pass the value of your FD. So you pass the address of your local variable. So actually, pass the address of local variable can make these two local variable point to a local variable in the main thread. The main thread local variable should not be accessed by other thread, right? Because ideally, we want the global variable, static variable, or heap can be shared to each thread. We don't want the local variable be shared. However, because they are in the same virtual memory, in the same process, so you can easily use pointer, point to the variable, even the variable is a local variable in other stack, if you have an address. So in this case, you use the local variable reference to another thread's local variable. So use the local variable inside your peer thread to reference to a local variable in your main thread. Okay, so what happens if we do this? So imagine that if we have, uh, let's just do some like a regular case. Okay, so the regular case is, okay, the main thread create the FD, so it's create a file descriptor. So let's say this file descriptor is 13. Okay, so it's create a file descriptor 13 and pass the address of FD equals 13. So right now we got this vargp for peer1. So this reference of FD. So if we want to do something, this will equal to 13 because this is a file descriptor 13. It's user address. It's user address of this FD gets the value of 13. So you can do this, right? Then we try to finish the first thread. So we finish this line, we finish this line, and we do x plus plus. Then we go back here. So we get another open file. So in this open file, we get another value, which might be, let's say 14. Okay, so it's got another file descriptor and pass into it. So based on this FD, the address of FD, you can access to this FD. So you got 14 here. So you got 14 here. Okay. So actually, in this case, in general case, this is good because each peer get a different file descriptor and they can use this file descriptor to run the program. So even though it's a sharing, it's okay, right? Even though they share something, they reference to the same local variable. Even though they share the local variable, it's okay because they can get uh, different number of the file descriptor. So it's on purpose. It's on purpose. Okay, this is good. However, there's another situation might happen here. If you have unintended sharing and you did not check it very carefully, there's another case might happen. Let's see this example. So if you have this example here, first one, again, your main thread is 13, you pass the address of FD here to this one. So here is reference to address of FD. And right now, you think you should run this one, right? You should run this one. But actually, no, it's sleep. So let's see. This is sleep. This is sleep. This is away. Okay, if this is sleep, which means you haven't run anything inside this, then your program just do S++, then go back. In this case, it will update this thread to, for example, 14. Then, right now, this one go to sleep. And this one wake up. So in this case, the this like a variable still referring to FD, and FD right now is a 14, so it's got 14. Okay, so in this case, it does not get 40. And another part is, okay, so right now you just, this one just go to sleep. And the main thread run this line. The main thread run this line. So create a peer 2. So peer 2, now there's a reference from the local variable to the FD. And here, right now, the main thread go to sleep. And your peer thread, peer 2 thread wake up. The peer thread to wake up based on the FD here, which is reference to 14, so it's right 14 here. So actually you can see in this case, both peer got the same file descriptor. So if you try to assign different file descriptor to different thread, then it's fail. Because what? Because of scheduling. You cannot guarantee when this peer thread 1 sleep, when this peer thread 2 sleep, when the main thread sleep. You don't know what's the who go first, who go later, and you cannot control the order of this because it's all about the scheduler based on your process. So because of this, you got some unintended sharing. This is unintended sharing, and which cause rest condition. So what's an unintended sharing? If you want to share something, but you don't perfectly predict the behavior, we call it unintended sharing. So something should belong to the thread itself. Like, for example, the local variable should belong to itself. But you try to like reference to this local variable by some way because they are in the same process. So you can use memory address to point to the local variable. And if you do this and you did not take care of it, you will get rest condition. Rest condition means in different case, in different schedule, you will see different result. So in this example, the peer 1 and peer 2, they can both get the same value of file descriptor, or they can get a different value. Depends on the schedule, like a scheduler to decide, depends on the scheduler's decision, who wake up first, who wake up later, okay? So this is the idea of the unintended sharing and rest condition, and it's dangerous. It's not a good stuff. It's hard to debug. It's hard to find. You probably like run 100 times is successful. wrong, but just one times, like by accidents, the peer one and peer two, they got the same file descriptor and they broken the file you try to like write. Okay, so that's a lot of case. Actually, the real world like a situation, the case happened because of this bug. Okay, so this is about the unintended sharing. So this is for today's lecture. Today we mainly focus on the sharing. Sharing is definitely a good stuff. We want to share, so we use thread. We want the thread can share data to each other, but be careful about the unintended sharing and rest condition. So because with the rest condition, you will get some unexpected result, the output from your program, and it's really hard to debug. Okay, so we will talk about a little bit more about how to analyze this sharing in other video. If there's a risk condition, how to solve it, we will cover this in other videos. Okay, so I hope you enjoyed today's video. So see you next time. Unintended sharing is dangerous.